Hello everyone. The topic that we will be discussing is from the chapter of electrostatic potential. And now we will discuss electric potential due to a point charge. So let us first go to the definition. What does this electric potential mean? Electrostatic potential at a point is the amount of work done per unit positive test charge by an external agent in moving it without acceleration from infinity to the given point against the electrostatic field along any path. Okay? Basically, this electric potential is denoted by a symbol V. And one should be noted that this potential, okay, is a scalar quantity. So electric potential is a scalar quantity. Okay. So now let us consider a point charge say Q located somewhere at this point say O. Okay. So now we want to find the electric potential at this point A. Say the distance of this point A from this charge, it is RA. Okay. So by definition, electric potential at A, so VA, is given by W infinity A divided by Q naught. Okay. So this is somewhere at infinity. Okay. Now, let the test charge Q naught be at P at any instant. Suppose somewhere here there is a point P. Okay. Then the charge Q naught is somewhere here at this point P at any instant. So if this P is at a distance x, okay, from O, then what is the electric field at P? The electric field can be written as 1 by 4 pi epsilon naught then Q divided by R square. Okay, so this is the electric field at a point P. So let us consider that this charge, point charge here, it is plus Q. So the electric field, it is in this direction. Okay. Then since this charge particle must not accelerate, therefore the external force to be applied must satisfy this equation. This is external force must satisfy this equation. Q naught E, F plus Q naught E equal 0. Okay. Then this implies that F is nothing but minus Q naught E. Okay. With the apply of this external force, suppose this charged particle, it is moving in this direction. Okay. Say the distance is dl. Okay. So if dw is small amount of work done, okay, in moving this charge Q naught to a distance dl, so what is dw? dw is equal F dot dl. Okay, so here instead of F I can put Q naught E, so this is dot dl. So clearly from here E and dl, they are in opposite direction. So the angle between dl and E is 180 degree. So as we know that if we have two vector A dot B, Then what is A dot B? It is mod of A, mod of B, then cos of theta. Here theta is the angle between two vectors A and B. So this can be written as minus Q naught. So mod of E is simply E. Then mod of DL is simply DL. Then cos, the angle is 180 degree. So what is cos of 180? Cos of 180 is minus 1. Okay. Cos of 180 degree, it is minus 1. So if you substitute here, we'll have Q naught, then E dl. Okay. So here, minus 1 from here with minus will get cancelled. So we'll get plus. So now, what is dw? dw is equal to Q naught. Instead of E, I will put by. So this is the magnitude of electric field at a point P. So 1 by 4 pi epsilon naught. Then Q divided by x square dx. Okay. dl. Here is dl. As we can see from here, this dl, okay, this dl is in the direction of decreasing x. dl is in a direction of decreasing x. Okay, so therefore we can write dx is equal minus dl, or dl is equal to minus dx. Okay, then if we substitute this equation here, we will have dw. This one is 1 by 4 pi epsilon naught. This q and q naught. Then divide by x square with minus dx. Okay. Now we want to find the amount of work done in bringing what? This q naught from infinity to a point A. Now let us integrate dw. This one is 1 by minus 4 pi epsilon naught. Then q naught. Integrate here from r equal infinity to a distance r equal ra. Okay. Then 1 by x square dx. So integration of dw, this one dw with this integration sign will get w. Okay. This one is minus 1 by 4 pi epsilon naught, then q naught. Okay. If we integrate this, okay, so see here, if you integrate this, so 1 by x square dx, this can be written as, okay, integration of x to the power minus 2 dx. So apply the formula, apply this formula, xm dx, we can write xm plus 1 divided by m plus 1. So here m is minus 2. So therefore, what is this equal? So minus 2 plus 1 will have x to the power minus 1. Then divide by minus 2 plus 1 will have minus 1. So the answer here, it is nothing but, okay, so this integration, it is nothing but 1 by x, so with minus. Okay, 1 by x with minus. So therefore, the integration of this is 1 by x. So we'll get here minus, and minus will become plus. So where's the limit? This limit, it is from infinity to ra. Okay. So here, the upper limit is ra, and the lower limit is infinity. So now, this w, okay, we can write w infinity a. This q naught we can take to the side, we'll have q naught. This one is equal to 1 by 4 pi epsilon naught. Then instead of x, I can put by 1 by RA minus, instead of x, lower limit is infinity. I'll put 1 by infinity. But anything divided by infinity is 0. So now, this W infinity A divided by Q naught is nothing but the potential at A. So hence, VA is equal to 1 by 4 pi epsilon naught Q divided by RA. So now, we will discuss electric potential at any point on the axial line of an electric dipole. Okay, so now let us consider a dipole. This one is minus Q, this one is plus Q, separated by a distance 2L. Okay, two charges, minus Q and plus Q, separated by a distance 2L. So somewhere here, this is the center of a dipole. So somewhere here is a point P. This point P is on the axial line. Let R be the distance of this point P from the center of the dipole. So it is clear from here that this one is L, this one is also L. So say this is A and this is B. So what is the distance between 2 points B and P? The distance between B and P is nothing but R minus L. Okay. And the distance of a point P from A, it is nothing but R plus L. Now, if V1, okay, is the electric potential at P due to minus Q, and V2 is the electric potential at P due to plus Q. Okay, so what is V1? V1 is 1 by 4 pi epsilon naught. The charge is minus Q. What's the distance of a charge minus Q from P? It is R minus L. Then what is V2? V2 is 1 by 4 pi epsilon naught. Then charge is plus Q divided by R plus L. No, V1, it is R plus L, and V2, it is R minus L. Okay. So if V is the net potential at a point P, so what is V? V is the net potential at P. Then we'll just add V2 plus V1. So here, Q by 4 pi epsilon naught, they are same. So I will take common 1 by 4 pi epsilon naught. Okay. So Q. So here I'll put 1 by R minus L. Then plus into minus will get minus. So 1 by R plus L. Okay. So from here, I can write V is equal Q by 4 pi epsilon naught. Then the LCM of R minus L and R plus L, I will have R square minus L square. Okay. Then from here, if you cross multiply this to this, you will have R plus L. Okay. Then minus, then R minus L. Then from here, what we can write, this R and R will get cancelled. So we'll have, so minus minus become plus, L plus L become 2L. So Q twice L divided by 4 pi epsilon naught, then R square minus L square. So what is this Q into 2L? This one is nothing but P. Okay, the magnitude of the dipole moment. So R square minus L square. Okay, so this is the potential, the net potential at P. Now, for short dipole, okay, for short dipole, R square minus L square is approximately equal. We can write R square. Okay, then in such a case, then what is V? V is equal 1 by 4 pi epsilon naught, then P divided by R square. Hence, for short dipole, okay, for short dipole, V is inversely proportional to R square. So now, we will find the expression of the electric potential due to an electric dipole at any point on the equatorial line. Electric potential due to an electric dipole at any point on the equatorial line. Okay, so now let us consider an electric dipole. This one is minus Q, this one is plus Q. Say the distance between minus Q and plus Q, it is 2L. Okay, say this one is the center of a dipole. So somewhere here, okay, at this point, we want to calculate the electric potential. From here to here, it is L. From here to here, it is L. Now, from here to here, then say this one is R. So from here to here, it will be R square plus L square. Similarly, if you apply Pythagoras theorem, this point BP, or this length BP, it is root over R square plus L square. Okay, so now if V1, okay, is the electric potential at P due to minus Q, so what is V1? V1 is 1 by 4 pi epsilon naught. Then the charge is minus Q. What's the distance? It is root over R square plus L square. Then what is the net potential at a point P due to plus Q? It is V2, 1 by 4 pi epsilon naught. Then the charge is plus Q divided by root over R square plus L square. So what is this V2 here? V2 is electric potential at P due to plus Q. Okay, so if V is the net potential, so V will become V2 plus V1. Okay, so as we can see from here, V1 and V2, okay, they are equal but different in sign. V1 is with minus Q, V2 is with plus Q. So what is V then? V is 0. So hence, the electric potential due to an electric dipole at any point on the equatorial line is 0. So now, we will find the expression of electric potential at any point R, at any point P, R, and theta due to an electric dipole. Okay, so let us find V. Now, let us consider a dipole. This one is minus Q, this one is plus Q. Then the distance from minus Q to plus Q, say it is 2L. Somewhere here is the center of dipole. Say the potential to be calculated is at this point, PR theta. Let us join this point P from the center. Let us mark this one by R. Okay. Say this one is A, this one is B. Say this one is theta. Okay, this angle between R and AP is theta. Now, if I join this line like this, and I join this line like this, okay, then let us drop a perpendicular somewhere here. Okay, let us draw by this. Okay, say this point is N. If I produce this one backward and I drop a perpendicular from A, let me mark this one by N. Okay, say this angle is theta. Okay, so as we can see from here, what is ON? What is ON? ON is equal to L cos theta. Okay, if we use this like this, this is 90 degree, this is angle theta, this is L, this is O, this is B, this is N. So here the base is ON, cos theta is base divided by hypotenuse is L. So ON is L cos theta. Okay, so similarly here in the case of OM, okay, this like this one is theta, this one is A, then O, this is M, this is 90 degree. Okay, so this is 90, this is 90. Okay, so what is cos of theta in this case? Base, it is OM, then hypotenuse is AO, which is L. So what is OM? It is L cos theta. Okay, so therefore what is OM? OM is L cos theta. Okay, so this length BP and this NP, they are almost equal. BP is approximately equal to NP. Okay, so what is NP? NP we can write OP minus ON. OP minus ON. Therefore, what is this NP? We can write R minus, instead of ON, we can write L cos theta. So similarly, for this MP, so this AP, it is approximately equal to MP. So this is equal to, instead of MP, I can write MO plus OP. MO plus OP. So here, this OP, it is nothing but R. This MO or OM, it is L cos theta. Okay. So if V1 is the potential at P due to minus Q. V2 is the potential at P due to plus Q. So what is V1? V1 is 1 by 4 pi epsilon naught. Then the charge is minus Q. Okay. Then what's the distance? It is nothing but AP. But what is AP? It is approximately equal to R plus L cos theta. Okay. And what is V2? V2 we can write 1 by 4 pi epsilon naught, then plus Q, then V2. Okay. So the distance of a point P from B, okay, is approximately equal to R minus L cos theta. Okay. So now, if V is the net potential, so what is V then? We can write V2 plus V1. So from here, V, Q and Q, I can take common. 1 by 4 pi epsilon naught also common. So Q divided by 4 pi epsilon naught. So here, I will remain with 1 by R minus L cos theta, then minus 1 by R plus L cos theta. Then from here we can also write Q by 4 pi epsilon naught. Okay. So what is the LCM between R minus L cos theta and R plus L cos theta? It is R square minus L square cos square theta. Okay. I cross multiply this. I'll have R plus L cos theta. Then this minus R minus L cos theta. Okay. So this R and this R will get cancelled. So here we will remain with Q by 4 pi epsilon naught. Then L cos theta and L cos theta is 2L. Okay. Cos theta divided by R square minus L square cos square theta. What is Q into 2L? It is nothing but dipole moment, the magnitude of dipole moment. So P cos theta divided by R square minus L square cos square theta. Okay. So next, special case. Number 1. If theta is equal 0 degree. If this angle is 0 degree, what does it mean? This means that the point P is on the axial line. The point P is on the axial line. Okay. So if theta is 0, cos of 0 is 1. So here also cos of 0 will become 1. So what is the potential at P? So 1 by 4 pi epsilon naught. Then P divided by R square minus L square. Okay. Number 2. If theta is equal 90 degree. Okay. So this point P now. Okay. It is somewhere here. This one, this point P, somewhere here, if theta is equal 90 degree. Okay. That's mean if we drop like this theta will keep on increase up to 90. Similarly here, in the case 1, if this point P is somewhere here, okay, what's the angle? The angle from theta will decrease to 0. Okay. So this one is theta is equal 0 degree. So if theta is 90 degree, the point P is on the equatorial line. Okay. In that case, as you can see from here, that if theta is 90 degree, so what is cos of 90? Cos of 90, it is 0. So the potential, it is 0.